Right, so now we might able to invite Team 2, so it's the Hong Kong Polytechnic University. Thank you. You will have 8 minutes for the presentation.
Ladies and gentlemen, have you ever experienced the sheer horror of being trapped in an iron house engulfed in flames? The anxiety of standing at the emergency staircase queue as you begin to distinguish the very characteristic smell of smoke. The deep and humbling sorrow of having to abandon all of your belongings in order to flee for your life. Hong Kong has a very long history of fire accidents, spanning all the way from the Happy Valley racecourse, which claimed more than 600 lives, to the most recent tragedy in Tai Po, where 168 people have perished and hundreds of families have been displaced. Although only a few most disastrous fire accidents have been covered by the news, there are many more than what one may think, and apart from ruining lives, they also deal significant financial blows to the city's economy, impacting society as a whole. So why don't we prevent it? Well, traditional construction site fire inspection over-relies on pre-work briefing, which is mostly ineffective, manual site inspections, which although effective, occur too sparsely to prevent spontaneous disasters, and weekly or monthly even reviews, which involve so much bureaucracy that they make fire inspection more reactive than preventive.
So given these grave dangers, our utmost importance should be directed towards saving hundreds of lives and millions of dollars in economy. So what is the solution to this problem? The solution is Sky Shield, a drone-based inspection layer that expands human situational awareness. Sky Shield works in four simple stages. Stage number 1 is monitoring, where autonomous drones fly, they acquire data, RGB and thermal data, as well as send all the raw data feedback to the system. Stage 2 is perception, where the system detects visual hazards and thermal anomalies and produces multimodal hazard evidence. Stage number 3 is analysis, where the current data is compared with historical data, as well as the system provides users with prioritized risk reasoning. And the last stage is visualization, where the supervisor is provided with intuitive dashboard panel showing ranked alerts and detailed inspection reports and evidence output. So as you can see, our system doesn't only provide raw data, but it provides actionable insights, increasing human situational awareness.
Moving on to our visual system, we combine radiometric thermography with visual AI. This includes hotspot anomaly logic and persistent checks. So we don't just ask the question, is this area hot? We ask the question, is this area unexpectedly hot? And does that heat persist over time? So to put it in simple terms, our thermal analysis asks the question if this area is abnormal, and our visual AI will answer the question by saying what is happening there. So what makes our system so efficient? It's because we don't just stop at the detection. We take it further by making it more credible and also giving it priorities. So as you can see here, each zone and inspection sites will have its own final fire risk score. This score will be evaluated by these 5 factors. Each of these factors will have its own weighting. We will also consider our model's confidence, and finally, we'll get our credibility output. This output will allow us to give each inspection its own priority level. So here we have our full workflow. We begin on your left with our drone inspecting data, and it will input it into our AI detection model. It will be evaluated by those factors, and we get our credibility scoring. From here, we have 3 different levels: high credibility, medium credibility, and low credibility. High cases will be acted on immediately with no further delay, and medium credibility cases will be flagged for further review, whereas the low credibility cases will be kept uncertain and be left for human judgment. So this gives the supervisor a clear idea of which cases need their most dire attention. So the final goal isn't complete automation, it's sharper human judgment with supported evidence.
So everyone, now let's look into the user interface of our system, which basically shows the number of risks, the severity of risk, and also the details. So now the question is, what makes the SkyShield more attractive? So basically, we can conduct more than 2,000 inspections per month, whereas a manual safety officer can only conduct one single inspection per month. So hence, we are optimizing a system by 2,000 times. It's becoming more efficient. Also, when we talk about the monthly service cost, the manual safety officer monthly salary is around 40,000 Hong Kong dollars, whereas SkyShield costs around 10,000 to 14,000 Hong Kong dollars. So we are reducing the cost by 70%. So our benefits are very clear. At first, we provide faster inspections. That means we have optimized our inspection cycle within just 20 minutes. Second of all, we provide broader inspection frequency. That means we can conduct inspection and monitor around 24/7 in comparison to a monthly manual standard where it's done once a month. And lastly, value. We deliver around 70% reduction in the recurring operation costs. So with SkyShield, we aren't just saving money. We are providing a broader, smarter, and faster shield for every construction site.
So for our core target customers are large contractors in Hong Kong. And now in Hong Kong, there are around 26,000 contractors. And last quarter, there are more than 1,600 active construction sites, which is in Q4 2025. And our revenue model is subscription-based. For one site 1 month, we charge 10,000. And for one site 1 year, we charge 120,000. So if we got 10 sites, we can, our annual revenue will be 1.5 million. So for our annual cost, we have two kinds of costs, including variable cost and fixed cost. Variable cost is around 68,000, and the fixed cost is less than 500,000 Hong Kong dollars. After calculation, our break-even point is around 10 sites. So that means after this point, we are profitable. And we plan to acquire our customers through direct B2B outreach, and we demonstrate our product through technical demos and start with a pilot site.
Okay, so this is our 4 years development path. We plan to do it from system validation and to commercial pilot and then local scaling and then finally platform expansion. So another growth opportunity is the Northern Metropolis. The Northern Metropolis itself signals a massive future market. According to the Hong Kong government, there will be around 500,000 new housing units and over 1,400 hectares of developable lands in the coming decade. That means long-term and continuous construction activity will persist in the future. So what we want to emphasize in the end is that our project is not driven by profit alone. Yes, we believe it has strong business potential, and yes, we want to scale it into broader market, but the bigger purpose is safety. If our system can help detect risk earlier and prevent fire before they spread, then it is doing something that is more important than creating revenue. Our long-term vision is to get our services recognized by the government, work with industries, and bring this technology to more regions, and use innovation not only to build a business, but also to help protect lives. So we believe that a successful business creates value and a meaningful technology protects people, and we would like to do both. Thank you.
Right, thank you very much. The time is up. So now I'll pass the time to the judges for the 12 minutes Q&A session. Judges, please. Thank you.
Yeah, thank you for your presentation. May I ask the first questions? What happens when weather, wind, or signal loss that affect your accuracy and usability? In fact, drone itself will also reinforce the wind nearby the fire site, and that may also affect the original purpose of your solutions. How would you consider that will affect your business model? Now you said that about half a year you will get break even, but if it is the case that because of all the natural disaster or whatever, that uncontrollable factor, your solutions can work. You may even have to reimburse the prepaid maintenance or service costs that the clients that you got from. So have you considered that?
So first,
Let me answer the question. Thank you for the question. First, let's talk about costs first. You talked about the, let's go to the slide about the costs. Okay. Yeah, you talked about some service costs and etc. And that's why we have backup drones and other costs. We already, as we said, already consider it that as a fixed cost because we need to cover it at some point, and that's why we have some backup drones. We have some other costs that includes in this revenue model, and that's why we still believe it is and will be profitable after 10 or so sites. And also talking about the wins and other things, we know that, for example, there could be, as we said before, there could be some pilot demos and etc. We could employ autonomous or non-autonomous movement, and autonomous movement could be done using a SLAM algorithm, if you know, the spatially localized automation mapping and etc. And the pilot drone could be also eligible for that, and that's why we have some labor cost employed in that. The personnel can work on that, and that's why we have some R&D costs. We're gonna develop our model and try to fix in this first year these problems. And in the end, we believe we're gonna be a profitable and sustainable company in the future.
And I also want to add something. Since we have this uncertainty measurement algorithm, so if, let's say, if there's a wind and our drone cannot take the images properly, then it will we have a penalty term here, so that if the image itself is not that clear, then the credibility of this image or the alerts generated by this image will be less prioritized, which will be maybe a medium or low credibility class. So that will also remind the human that our system, because we can consider of the uncertainty. So yeah, the human will do the final judgment based on the credibility score that provided by the system. Yeah, thank you.
Thank you, and it's a very interesting presentation. Thank you. So about the drones, so I presume the construction site will be changing rapidly from time to time. So you need to fly in lots of time over the drones in a city, a condensed city in Hong Kong. So how would you deal with the regulatory matter, especially when you have lots of drones flying over the skyscrapers?
Yeah. So actually, this one, let me wait a second. So I assume that the question is it legal for drones to fly around the site? So we checked, and the answer is yes. So we can see prior permission from the Civil Aviation Department of Hong Kong. And in fact, that Housing Authority also already utilizes the drones in building facade inspection. So this is a existing technology that have been used for the Housing Authority to do the building facade inspection. So we think that it is achievable and feasible in the future. Thank you.
Thank you for your presentation. Sky Shield, a great idea. 4 questions. First one, other than fire risk, what are the other risks and other detection that you can possibly think of, maybe down the road, so that your company is more than a one-trick pony? Second, revenue stream, have you thought about working with insurance company to get, better revenue enhancement? Third, there are building inspection startups and sophisticated company using drone to inspect buildings. What is preventing them to get into your market where they are stronger in technology, more sophistication, higher volume of data and all that? What is your differentiation against that competition? And last but not least, are the construction companies wanting you to do this? You will expose them on construction compliance from time to time, which they may or may not like.
Okay, thank you for the question. It is a very good question. And let me answer for the, let's keep it. Let me answer for the first question. We also consider the ideas of how we can develop our project in the future. It is also, I think, present, the hill fires that is present in Hong Kong. And I think we can employ the similar system to detecting the hill fires, which would be useful for the government, because the hill fires could also lead, for example, some casualties for the people that are hiking, and also hill fires could lead to the buildings or constructions and being near the, for example, Maoshan or etc. And I think this problem is even more prominent in some other countries like Greece, where the hill fires and some forest fires affect more. And in that sense, the hotspot detection is actually more useful and will be more feasible, because this hotspot detection will find these persistent hotspots that would lead to detection of such systems. And so we believe at least we can consider the forest fires or the hill fires, for example, in Hong Kong, which would be a feasible market and a very big market, I think, in the future.
As for the potential future markets, including insurance companies, that is true. That is a brilliant idea for future expansion of our project. But for the purpose of our first initial stages, we sort of focused on a single market. We also, apart from insurance companies, as you mentioned, that is a very good idea, we also considered cooperating B2G with the government for government-mandated fire inspections, as that would also sort of help with the compliance issue you brought up, that some companies may not want to have such a sort of watchdog over their construction sites, but the government would surely be interested in that. About the
competition.
Competition, yes. About the competition, that is a valid point. First, we may also consider the opportunity of selling our technology to a company that could utilize it for its best potential. Apart from that, about protecting, the best strategy here would be to sort of pierce the market first and establish connection support from the government and companies so as to leave less room for the competition. And for the compliance,
Can you answer quickly? Because I think Professor has another question.
So for the third question, we also can work, for example, with alumni of PolyU jointly and work with their companies, and that's why proceed further in the market. And about the last compliance, it is you maybe know that a main contractor is not only responsible for the fire hazard and fire safety, it also the fire department of Hong Kong, the building department of Hong Kong is responsible, and actually the monthly inspection is done by the fire department of Hong Kong. So the government is responsible for issuing fire hazard abatement notice, which also could lead to that main contractor could be either abstain from this project or could be delayed. And that's why it's not the essence of that main contractors don't want the watchdogs. It's a government is also interested in these things because it is like a traffic management system, for example, or something.
Yeah, I'd like to ask some fundamental question. And have you studied what caused construction fire? You know, especially who caused it, what caused it, and when does it happen? This is the first question. And the second question is, why do you think the drone inspection would help you in detecting fire, especially in adding the thermal sensor?
So for the first question, first, thanks for your question. For the first question, if we look back at the tragedies that happened before, so for the Taipo fire, the believed reason of the ignition, according to the news, is on-site smoking. And for the so there's a lot of different reasons that ignite the construction site, but the main reason will be hot work and maybe on-site smoking, and maybe there will be combustible materials, since lots of construction materials is combustible or flammable. So maybe these are the main reasons that cause a construction site fire. And for the second question, if you can look outside the window, there's scaffolding here and there's workers walking on the scaffolding. So imagine if there is a worker that's smoking here. How come a human can detect this behavior? But with the drone, we can use the drone to fly to that altitude and to use the thermal camera, because why we use the thermal camera is because when we are talking about flame, there must be three prerequisites of ignition, which is oxygen, combustible materials, and the temperature, right? So we use the thermal camera to detect the temperatures because it is a mandatory prerequisite for a fire that happens. So that if we are using a thermal camera, then it will detect the heat or the heat accumulating that may generate a fire. So yeah, that is why we are thinking about using a thermal camera.
You probably need more systematic and thorough understanding on what causes fire, because you only raise one point, which is smoking. And now, of course, the government is going to ban smoking in all construction sites. So the cause of fire is actually more than smoking. There are other things, so, and you really need to understand what exactly was happening in the construction site before. You say you know what to inspect. And I will argue with you that if your thermal detector, detects something, then the fire is already on. You are not preventing it. So you want to prevent it. So that's why I asked the question: why thermal detector? What value does it add? So you have to,
Right, thank you very much, thank you. All right, maybe you can reply to them afterwards, Sini. So now, because of the time's up, thank you very much for the poll, for the presentation, and thank you for the judges.